just means it has a fraction in it. So the first piece of this, what we're going to work on today and tomorrow, is solving equations with these fractions. So I think the best way is just to jump in and solve them. So let's say I gave you 2x minus 3 over 2 plus 2x over x minus 1 equals x. I want to solve this. One thing that we are going to have to be very careful on in this section is sometimes we're going to get answers that won't actually work. When I have fractions, what is the one thing that cannot happen? Zero where? On the bottom. So a lot of times what I do is just kind of make myself a note at the beginning what x cannot be. You don't necessarily have to write it down then, but if you don't make a note of this, then you're going to have to make sure and check every one of your answers. So when I'm looking at these fractions, does 2 ever equal 0? No. What would make x minus 1 equal 0? 1. So I know right now that x cannot be 1. So if I solve this and get x equals 1, what would I actually end up saying then?
No solution.
No solution. Okay. Second thing. Do you guys like fractions?
Nope.
Nope. So let's get rid of them. I'm going to rewrite this just to give myself a little more room. You don't have to do that. I just want to show you exactly what we're going to do. So there's really 3 pieces here. 3 terms. In this first one, if I wanted to cancel my denominator, what would we have to do? Just, which in this case, all we really have to do is multiply by that 2, right? But if you take one thing times 2, all right, so I'm going to have to take all of these times 2. So that would cancel this, but are all of my fractions gone?
No.
No, so we're not done. The second fraction has x minus 1 on the bottom, so I'm going to have to take everything times x minus 1. And again, whatever you do to one, you have to do to every one of those. So then that x minus 1 would cancel there. Are my fractions gone?
Yes.
So what I'm left with, here we have 2x minus 3 times x minus 1. Here I have a 2x times a 2. Over here I have an x times 2 times x minus 1. So we just have to start multiplying all this stuff out. So if I FOIL this first one, I get 2x squared minus 2x and minus 3x minus 5x plus 3. 2x times 2 is 4x. Over here, 2 times x is 2x. Can I go ahead and distribute that at the same time?
Yeah.
So that would give me a 2x squared minus 2x. Is everybody okay so far? So we need to add like terms. We have 2x squared, negative 5x and positive 4x is just negative x plus 3 equals 2x squared minus 2x. If I subtract my 2x squared,
It would just cancel.
So I'm going to add over my x. So I get 3 equals negative x. So x is negative 3. Double check. What was the only thing we said x could not be? 1. So negative 3 is okay. That is our answer. You can always check these just by plugging it back in the original. And if I did 6 minus 3 is 3 over 2 plus 6 over 2. Oh no, I plugged in positive 3, not negative 3. So if you put negative 3 in here, you would get negative 6 minus 3, so negative 9 over 2. Over here you would have negative 6 over negative 4, so that's plus 3 over 2. And that gives us negative 3, so it does work. So you can always check these at the end. Is that okay with everybody? Let's do another one. So
How'd you get the negative 3, the negative gets switched over to?
I just divided by negative 1. So x over x minus 5 plus 5 equals 5 over x minus 5. So what would we do here? What can x not equal? That's my domain. I know it can be anything except 5. So if I want to cancel, I'm just going to go ahead and rewrite it. I need more space than that. We have 3 pieces here again. So for the first fraction, to get rid of that denominator, I have to multiply by,
X plus 5.
actually just the exact same thing. You don't even have to do conjugate. When I do that, the x minus 5 drops here and here. So do we need to multiply by anything else? No. So in the first term, all we have left is x. Second one, I have 5 times x minus 5 equals 5. If I distribute, I get 6x minus 25 equals 5. Add over the 25. Divide, so x is 5. Yeah, we said x can't be 5, and we got 5, so that means it's no solution. So far, so good? Let's try just a couple more and we'll stop for today. What can x not be this time? 0. Alright, so to cancel my first denominator, we would have to multiply by 3x squared. So that would cancel this. 2x. It would also, but couldn't I already cancel one of these x's? So cancel out one of those x's. So really all I need to multiply by for this one is a 2. 2 times 3 is 6, so you could go ahead and cancel that. Is everybody with me there?
Where'd the x squared go?
It's still here. I'm going to have to-
On the bottom or
It's on the top.
okay.
So with what I'm left with, in the first term we have 7 times 2. In the second one, we have 9 times 3x. And then in the third one, we have negative 13 times x squared. So that's what we have at this point. This is a quadratic, so what should I do to that? Right, add that 13x squared over, and then we can do box method. Okay. Maybe not the nicest, but we can handle it. Okay, so 13 times 14, we need two numbers that multiply to 182 and add to 27. Anybody see it?
Fourteen.
13 and 14. Yeah. We have 13x and 14x in. So if we set each of those to 0, we get a negative 14 over 13 and a negative 1. Are both of those answers okay?
Mm-hmm.
Yes. So on this one we actually got 2 answers that worked. Questions there? I think I'm actually going to stop because I don't want to